Okay, now let's ignore notes right here for the moment. A house cost $200,000 in 2004, $300,000 in 2024. Want to find the average rate of change of the cost with respect to time. Okay, well, have a little trouble with that, not getting anywhere. So we break it down and then there's a much less trouble. Okay, so I mean, first of all, if you do work in this, ignore my questions here and figure out what the average rate of change is. And if you can't do that, then we follow. Okay, so, well, okay, now a couple of leading questions because some people have a little trouble with the whole applying the idea of average rate of change. Cost changes from what to what and how much does it change? Okay. Well, when I put the questions like this, I get good answers. Okay. So when you see something like this, something changes from something to something, and you know how long it took, you find the change in each one. Okay. In other words, you find the change in the cost. We're also going to find the change in the time. So how much does it change? Okay. So we want to then answer these by writing out statements. Because we don't write out the statement, we don't reinforce and focus on the fact that we're finding the change in cost. We just write down a couple of numbers. Now, 200K means 200,000, 300K means 300,000. I didn't have room to write out all the zeros, but we understand that at least what we have. Okay. And then how much does it change? Well, there's a logic here. Cost changes from this to this. So that's a logical connection. So not formal logical connection, but it's logic. The logic is changes from this to this, therefore, that's right, therefore. Cost changes what? Well, we also write out the arithmetic. We do to calculate that to reinforce the fact we're subtracting the earlier value from the later value, and that's going to give us the change. Now, that's all very, very important. You should understand all my words there. Okay, you should make this something that's just plain intuitive to you. And what I get is people writing their paper, they'll write $100,000, they won't write the rest of this out. Now, if I want a quick answer, then I want this. Okay, and that's the first thing you write down, but then fill in what you did to get it and what it means. Now, so we have a logical statement. The cost changes from this to this, therefore the cost change is this. Okay. Okay. So what's the change? In time. How much does time change? Is it change in time? No. Everybody wrote out a very good statement, said, that probably went right out of year there, but change, if you understand that this is a year, 2004. From year 2004 to year 2024. I'm going to write out the rest of the logic. Therefore, change in time is we subtract 2004 and 2024. Understanding that these are in years changes 20 years. So there's a little more detail here. You immediately got the 20. And got this statement. Yeah, the rest of the statement is valuable. So I recommend that when you do problems of this nature, and there are a bunch of them in the homework, you write out these statements on a piece of paper, because it'll stick with you. By the time you're done, you won't be able to go to sleep without dreaming about it. Okay? So, and better things to bring it up. My point is that it'll lock in your brain. And then you'll know what to do anytime you see a problem like this. Okay, so there we have it. Now, the average rate of change of the cost with respect to time. Well, I'm going to give you another lead. Well, first of all, can you take the change in cost and the change in time and tell me what the rate of change is? Okay, not getting a response in this, but that's okay. We're going to build up this idea. Right. The cost changes by $100,000 in 20 years. How much changes that per year? Well, some people got this and some didn't. One of the answers I saw was well, it's just 100 times 20. But that's $2,000. No, not $300. A dollar sign in front of 100. We'll do 100 times 20. That's $2,000. And you're not earning $2,000 per hour. Okay. Well, this isn't right. You'd make $2,000 per hour in 10 hours. You'd make $2,000 the first hour, $2,000 the second hour, and so forth. You'd make $20,000 in 10 hours. I'm sorry, it's in 20 hours. You'd make $40,000 in 20 hours. Okay, that'd be good money. Most people work 20 hours for $40,000. Okay, so that doesn't work. But you know, the good thing is that so there's a calculation that goes with it, but that's not the right calculation. What other calculation could you do with $100 in 20 hours? Or with the numbers 120. Okay, now another possibility is $100 plus 20. But this okay, it doesn't hold up because That would represent $100 plus 20 hours. You can't add dollars to hours. What's it mean to add $100 to 20 hours? What do you get? You don't get dollars, you don't get hours, okay? So these are unlike terms. Unlike terms, because they have different units. Okay? So we could multiply $100 by 20 hours, we get $2,000 hour, which could make sense in certain contexts, but probably not in the context that we're talking about. Okay? How about $100 divided by 20 hours? We get 5 when we divide 20 into 100. So we're dividing dollars by hours. And we get dollars over hours. Or 5 dollars per hour. This is the right calculation. We divide the change in one quantity by the change in the other. This is why we define. Average rate is by changing this divided by changing that. We got to sort out what this and that are. Okay. Now, that's an informal definition. We're given the formal definition. You might want to review it. I'll write it down again, but I'm not over there. So I don't want to bring it on in like I usually do. So how much change is this then per year? If the change is $100,000 in 20 years. Okay, so good. Okay, so the average rate is the change in this divided by the change in that. And you got to know which to use for this and which to use for that. But I'll explain that just a little more. But it's change in this divided by the change in that. What you wrote down was $100 over 20 years. Okay, now you want to put the dollars in the years there, but you have the numbers right, okay? And then 100 divided by 20 is, can you tell me what 100 divided by 20 is with your fingers? Yeah. Immediately, no hesitation, you're gonna get 5. And then what are you gonna get for the units? Remember that here. Let me write it down. Well, I wrote it down here. $100 divided by 20 hours gave us $5 over hour, right? Because the dollars are still in the numerator and in this case, it's years. Not in the denominator. So we have 5. And it's actually not 100, it's 100,000, right? Okay, so I think maybe I saw somebody write down 100, somebody, I don't know what I'm thinking. It's $100,000 over 20 years, which is 5,000. There. Dollars over years, well, that's red dollars per year, and that's what makes sense. Now, if you divided it the other way, you got like 0.002, okay? 0.002, sorry. But, and that would have been years over dollars. Years per dollar doesn't really feel right, doesn't make a lot of sense. And how much change is there per year, okay? Because it was changed per year, which tells us that the year better go in the denominator. Okay, well, that's your average rate. Now, I'm not sure I'm going to get to the formal definition of the average rate. Because I want to stay with the main thrust of this question, but hopefully we'll be able to come back to that. Okay, well, that's the average rate of change of cost with respect to time. Okay, and the definition of the average rate of change of one thing with respect to the other is the change in that one thing divided by the change in the other. Okay, so I can write down what we would calculate here. I don't have room to write out all the world's words, so I'm going to say the change in cost, because this delta symbol stands for change, and we need to be used to that. And I see a lot of it over change in time. And that's what we just did. We found the change in the cost. That's easy, we just subtract. We found the change in the time. You find a change in something, you just subtract what it ends up with minus what you start with, or you subtract what you start with from what you end up with. If you subtracted it the other way, you get a negative number, and that wouldn't make a lot of sense. I mean, it might make sense here if the cost is going down. With the change in time, you're going to want a positive number. And it was good that I saw a lot of people write down a plus. Well, plus 20 as a sign is important. Okay, so that's pretty good. Now, I want to put this information on a graph, because that's how we solve the kind of problems that you have. The problems, well, there's one way to solve the problem. You can do it with the words as well. That's not the method that I'm going to stress. Hopefully I'm making a good choice of that. I have 300 students here. I can do a statistical study and see what works better. First place, I don't like to experiment too much with my students. Second place, uh, if I got something that wasn't in fashion, everybody would ignore it. I'd be the only one that was convinced. Okay, well. Editorial comment there on the state of education research, but, that lot is good. Good fashion. Okay, so anyhow. I'm gonna do that. Okay, in this axis, I'm gonna put cost. In this axis, I'm gonna put time. Okay. So. The information up, and I'm sure it's visible on the screen. We'll just put it up here. So people who are watching video can remind themselves, so they don't have to move it off the screen. I zoom video that, but closely better. Closer you are, the less you can see me. So that's all. Okay, so anyhow, cost, time. Can you draw me a line? Time equals 2004. You draw me the line where time is 2004. And which way would that line go? It's going to be a vertical line or a horizontal line. Which way do you think it is? Which one are these about? Yeah, it's vertical. Okay, here's time. Time would be the same for all points on a vertical line. So I'm going to put 2004. And I'm going to use T for time, and I'm going to let Y be the cost. So here I can say T equals 2024. Now, if this is 0, and this is 2024, sorry, I want to do 2004 there, okay? If this is 0 and this is 2004, then 2024 is only 1% more than this. And you have to draw another line almost right on top of this one. And that's not going to be useful. So I'm going to put a break in the time axis, say there's a lot of time in this little break. Okay. So this is not on the scale. This distance here no longer represents 2004 years. Okay. Because there's a lot of time in here that isn't part of this distance. Okay, so can you sketch that? And then can you sketch a line for 2024? Well, I'm going to do that for you because you might not have a good idea how to do that with that break and everything. We haven't talked about that, okay? But since I've got a break here, that break could be as big as I want it to be. That break could be 2,000 years. Okay. Now, we can do another line. Whatever we want. We can make this break as big as we want. I'm going to put T equals 2024. Okay. Now, can you draw me a line? A line for cost equals $300,000. Where would that line go? Okay, now, we want the cost to be 300,000. I don't have to put the dollars on it because Y is cost in dollars. Okay? There's a little ambiguity in what I just said. Yeah, that's okay. So I'm gonna put the line up here. Y is 300,000 right there. Now, if Y is 300,000 here, where should I put 200,000? Okay, again. So we determined that everybody understood that 200,000 is closer to 300,000 than it is to zero. Not everybody coming into pre-calculus schools will understand that, because people use a calculator to do the numbers without thinking about it. So it's good that everybody was able to answer that. That was very good. And well, you know, halfway would be half of 300,000, that'd be 150,000. So if this is 150 and this is 300, 200 probably ought to go about here. And that's about what it looks like from the papers that I'm looking at. Okay. Now, that means that the information we're given can be represented by 2 points on the line. Because this point says when T equals 2004, Y is 20,000. Okay. You know, that way I always do it like 200K instead of 200,000. That's what this point tells us. Okay. And the coordinates are 2004, 300,000, or just 2004, 300,000. Understanding, and understand it because we've labeled it on the axes, understanding that this is T in years and this is cost in dollars. And of course, it's not 300,000, it's 200,000. I haven't lost my mind. I'm just imitating. Okay. So let's correct that. All right, well, what are the coordinates at this point? In a set of parentheses, fill in the coordinates. Okay, now, if you look at what I did here, there are 2 coordinates. There have to be 2 coordinates for pulling the plane. And you do this coordinate after this coordinate. This one goes first, that's called your independent variable, and then this one, which is your dependent variable. Okay, so this coordinate, just like we did here, this was 2004, and this line, okay, well, this line's 2004, this line's 200,000. So this has coordinates 2004, 200,000. So what are the coordinates here? They're 2024. $300,000. Okay. Now, I want to know how long this arrow is. Now, I'll comment that since these lines are parallel, any arrow that goes straight from this line to this line is going to have the same length. So I'll just say that, well, this arrow here is the same length. This one. And this one. So what's the length of that arrow? So I'll say here. The length is 20. So this has a length of 20. But here, since it starts at this point, and it's the horizontal part of a path from this point to this point, I'm going to call it the run. Thousand 2004. That's smudged, although it's still visible. Equals plus 20. Now we've seen that number right there, and then we see it right there and calculated. Okay. So it's the same thing we calculated here. It's the change in time. And that makes perfect sense because the time goes from 2004 to 2024. That's 20 years. Okay. It's about how old a lot of people in these classes are. Some are older, some are even younger. Yeah, but anyhow, so there's vector length 20. That's your run. Okay. Now, with this arrow, how long is this arrow? See if you can draw that arrow. Tell me how long it is. Just write a number next to it and then we'll fill the rest in. Okay, so from here to here, the chain, well, this arrow is 100,000 units long. If this is 300,000, this is 200,000. It's 300,000. Minus 200,000, that's squeezed in a little bit, but I think we understand that. Equals plus 100,000. Now we draw a straight line from here to here. And what's the slope of that line? First of all, what's the definition of slope? Slope equals what? Definition, not numbers, definition. And then we write out the numbers. Now, if you don't remember what the definition is, write out the number. Okay. There are two ways to do the definition. I prefer the more informal way first. Okay, so we see definition. I prefer more specifically, the rise is the change in y. The run in this case is not going to be changed in x because we're using t for time, but it's delta t, right? So the rise is change in y, run is change in t. And what numbers then we put in here? Okay, so what's change in y? What's a change in x? Change in y, rise, T, not X, change of T is a run. And so we just read that what the rise and run is, and we pictured it on the graph, right? So we don't have to refigure out what the rise is or what the run is. We've done it in the previous step. The rise is 100,000. It's not 300,000, not 200,000. It's not 250,000, it's the halfway between, it's 100,000, because very clearly this arrow has to have that length. And everybody saw that. Something that got a wrong number. Okay, and then you're changing T, well, changing T is a change from here to here, and that's what we call a run, and that's 20. That's 5,000. Meaning $100,000 over 20 years, which is 5,000 dollars in the numerator. You're in the denominator. That's red dollars per year, and it makes perfect sense then as a rate of change. So here's the slope. Now, I don't write the word slope up here necessarily. I think maybe calculate the slope over here. If I've got room, it's nice to write it a little bit closer to the triangle, but that's not always practical. So we've worked out the slope. But we are going to say $100,000 over 20 here equals $5,000, and we put a rectangular box around that to indicate that it's not a length, it's a slope. Again, that's my own notation that I like to use, just to give us a picture of the slope. So that when we look at this triangle, we can immediately see that T changes by plus 20 years. It's plus 20 and it's in years. And Y, the cost, changes by plus 100,000. Because Y is a cost, and it's cost in dollars, that's plus $100,000. So if we write it out completely, the meaning of the thing becomes clear. It's dollars per year. Okay. Then we notice that this is identical as a calculation we did for the average rate. So I'm going to make a big old statement here. This is the same as the average rate. Same calculation, same everything. Why? Because the average rate is the change in this divided by the change in that. This is your 100,000, that's 20 years. $100,000, that's 20 years. And that's your delta Y over delta T when you put it on a graph. Okay. Now, take a big step here. If we want to calculate what the cost of the house would be in, or what the value of the house might be in the year 2040. Okay, well, that's 16 years from now. We could multiply that 16 years by $5,000 per year. That gives us change in cost or change in price of $80,000. Okay. So we could make that calculation now that we have the slope. But what we do instead, and of course, it's actually no easier. There's a good reason to do it. And so now the equation. Well, like using comma over 200,000, that can be confused. That's too many commas. So just separate the last three zeros a little bit. So what's the slope of the straight line? Well, first of all, we use y equals mt plus b. Because we're using t for this axis, not x. So instead of x, we use t. Yep, that shouldn't be a big problem. This y equals mt plus b. So y is 5,000 t plus b. We just don't know what b is. So the question is, what's the value of b? Well, one way to answer the question is y is 200,000, and t is 2,000, 2004. Okay. So can you write this equation and replace y by 200,000 and t by 2004? You got y was 5,000 plus t plus b. What do you get? Can you write it out? Okay. Now, you substitute 200,000 for y. That means we got y here, you put in 200,000, meaning $200,000. Okay. And then you have an equal sign. Right to the equal is 5,000. The next thing is t. So this means 5,000 times t. T is 2004 when y is 200,000. And then it's plus b. And that's a dot. And I'm having trouble making a dot. The chalkboard board, my coordination. Well, this is an equation you can easily solve for b.